would like to talk to the class.
I'm trying not to hit the soundboard. Go ahead, Fed.
I made an observation using Stellarium. And this observation now Stellarium is basically your vision as far as I'm concerned. It mimics what we see with our eyes. So it's a celestial sphere with our vision. So they've gone and mathematically put a celestial sphere over an oblate spheroid, indicating opposing rotations. Makes sense logically. So the paradox is if the Earth is flat to our senses, but yet the heavens produce a opposing rotation, the assumption would be now to get opposing rotations, you would need a figure-8 sun on a planar system. So looking for an observation that would detail a figure-8 sun can be observed if you are in Africa, Campella, Africa, anywhere between the solstices or the equinox to the solstices, you will see it across the equator in opposed rotations, indicating that if you look at it conceptually, you will see that while as you're looking at it, it will appear on a plane system to go in opposing rotations. You can visually see it creating a figure-8. You can call it the sun analemma, but you can actually physically see this figure-8 take place. Like I said, that observation in Africa between the solstices to the equinoxes, whether it's January it'd be September till February, March roughly, and then from March till June or July, you'll see those transitions. And what it will do is it will make a figure-8. And if it makes a figure-8 in the sky, then if that's true, based on the observation, then it would give you the idea that you could have opposing rotations on a planar system because you visually see the figure-8 being made. It's just an observation. Whether it happens or not, I don't know. I'm just saying you can actually visually see the figure-8 being created in the sky from Africa. And that's what you would need to have opposing rotations on a planar system.
Well, I have a couple problems with that. When you say the figure-8 is required for two rotations, to the opposing rotations, you're talking about like over the course of a year where the sun goes around one pole and then goes around the other pole the other half of the year, right?
So if you look at this observation for Stellarium, you will see that exact pattern. You'll see it traverse in the north in circular motion, and as it proceeds through its incrementally position change daily. In other words, it doesn't return to the same spot every day. It shifts through, right? So it's like an oscillating circle.
It's my point.
So as you see this oscillating circle move through the solstices, so the equinoxes to the solstices, you can see it traverse over the equator. And when it does that for the whole season, from obviously the 365 days, the complete circle of it, you will actually see that it makes a figure-8 in the sky from Africa. And if that's the case, well, then that would give you opposing rotations on a planar system as far as you visually see it at that perspective. Whether that's true or not, I'm not saying. I'm just saying that if you needed an explanation for opposing rotations, that observation facilitates the opposing rotations, which would give you the illusion on a plane surface that you have those rotations just from that observation. And at least that's the way I see, because it creates a figure-8.
Yeah,
right. I think the
why do you keep saying in Africa? Why does it keep saying in Africa?
Because that's where the observation's made. So if you go to Africa, Campanella, it's the closest point to the equator that I found, because you want to be closest to the equator. And what you want to do is you want to face east, and you want to look zenith. So you want to face east so you can see it rising. And when you face east during the September 10th, as an example, September 10th to September 20th, you will see as you go into Stellarium and you speed up the program, so you see it cycling through its motions. You will. Why you keep getting interrupted, man? I'm explaining what to do. I'm explaining what to do. Anybody can do this observation and use Stellarium and go verify it for themselves. It will create a figure-8. Which, if you're in Africa, looking east and you're facing east, but you're looking at zenith, you will see the sun have opposing rotations, which wouldn't work necessarily on your sphere, unless, of course, you contort it and it doesn't actually go that full direction as you're looking up zenith. It would have to completely go around the Tropic of Capricorn for a sphere. But that's not what we see in Africa. You see it go the opposite direction in the north, which would give you a figure-8, which would be, in my opinion, an explanation for opposing rotations on a plane system. That's what it appears from that observation.
So the figure-8 that you get from the analemma is not the same kind of figure-8 that you're talking about.
Real quick, Manu. I got muted so he could do that. Can I just follow up real quick? FED, when I ask you a quick question, I don't need all that. So from Africa, you're saying because it has the perfect figure eight, you agree we get the analemma pattern everywhere, but are you focused on the perfect figure eight from the close to the equator point? Is that why
I'm not really focused on the analemma right now. I know the analemma exists. I'm just looking for evidence for opposing rotations on a planar system. And the only way that would occur is if there was a figure eight sun. By this
Doesn't have to be a perfect figure eight. FPD, I got it. Let
I'm
me
almost done,
continue.
guy. I don't know why you keep
Let me ask
interrupting.
you a
By this
follow-up.
observation,
Because
you can see a figure eight. You can see a figure eight being created. You can speed up Stellarium and watch it do
oh
its
my
yearly
God, mute
cycle.
him, mute him,
You can watch
not
its
me,
yearly
mute
cycle.
him,
Go to
mute
Stellarium,
him.
download it. Go to
Got to be the perfect figure eight, or what if we go to different latitudes and it has the big circle, little circle infinity sign? Will that qualify for his double rotation, or is that where you only get a globe? Can you have that on a planar thing, FPD?
So the observation I have made has only been from that particular location because I was looking for evidence of a figure eight sun.
Well, you don't know.
That particular observation offers a
Yes, no,
figure
or I
eight.
don't know.
Why do I keep getting interrupted completing
Yes,
sentences?
no,
I don't
or
know,
I
bro.
don't know. I have a follow-up, bro.
I'm almost done.
Yes,
I'm
or I
almost
don't
done.
know.
So anybody
All right.
going and making this observation can clearly see a figure eight over the year season. You'll clearly see it. Now, whether it's a small loop or a big loop, this is irrelevant. The fact it makes a figure eight across the sky is what's relevant.
All right, go ahead, Manu. Don can't stop screaming.
So I think it's not irrelevant whether it's a small loop, big loop. I think because that is the analemma basically you're talking about. If you're just talking about a figure eight, you can translate the globe into a flat plane with two poles, and that will give you a figure eight. When you say that we observe a figure eight, I don't think that's true. What we observe is just one sort of east to west motion, right? Like the fact that it creates a figure eight is something you have to sort of project onto a different figure. But what we see, I don't think qualifies as itself a figure eight.
Even if it makes a figure eight, it still makes it east to west rotation,
It shouldn't.
right? Well, that's what it does. If you do it right, it'll still do it. It'll still do the east to west rotation on a plane Earth.
Well, it depends on how you set up the plane Earth, I suppose. But your east and west is going to get really funky off at the edges. Like if you're just in the center talking about the one rotation over your head, you cut off like the two half circles far north and far south. I guess you could say that. But if you take the
Just
whole
go.
figure eight in complex, you're going to get different direction rotations.
You do, but it still ends up to be. If you go look at how I put a picture in the chat outlining what Stellarium has for its path. It still travels east to west, even though it crosses. The circle still created east to west path, even though it's an opposite rotation through this through this infinity symbol, if you will. Because if it still rises in the east, but it changes directions instead of northwest, it goes southwest. So it still rises in the east, but settles southwest versus northwest. And when you observe this, so if you observe this from Africa and you look east and you look up at the zenith, you'll see the sun create these circles. They will be in opposition, but still rising in the east and still setting in the west.
I don't see what you posted in the chat.
I'll do another one for you.
I would have to look up wombat poop.
But it's a real world observation because I had AI check it. It matches real world observation in Stellarium. All I did was draw it out just to think about it a little bit more. And yeah, so it creates the right circle motion that you need. But of course, now you have to apply that particular motion over what we've been given for coordinates for, positions of land masses. So now we have to apply that observation to a model that I can't verify whether the map is correct or not, right? But I can verify that observation is real, the opposing rotations from Africa. But how to apply that to a map that I can't verify the detail of the map, except for small scale. I can detail it or find accuracy in small scale, but large.
Well, I think
that, I can't verify whether the map is correct or not, right? But I can verify that observation is real, the opposing rotations from Africa. But how to apply that to a map, that I can't verify the detail of the map, except for small scale. I can detail it or find accuracy in small scale, but large scale in totality, it's impossible.
Well, I think the problem with this, if you're going to put this over a map, that map is going to have to somehow either, you're going to have one of those Pac-Man maps, or
Not
you're going to have
necessarily. Not
really
necessarily. It
weird.
would be. Yeah, it'd be weird. You're right, because what we're so used to seeing, as far as the circling of Antarctica, we're so used to seeing the landmass of our Antarctica, mapped out. So yeah, of course, it's a conundrum now, because now where does it, because that observation creates a circling sun in opposition, which would give you the idea it works on a plane system, because it's showing you figure eight, right? What's the point of a figure eight? You can see the figure eight happen, which you would need on a plane system to get opposing rotations,
Can you
right?
go?
But well, that's the way
You
I've tried
say
to
you can
model
see
it.
the
I've
figure
tried
eight.
to. I've tried to model it. I mean, it's not, the globe is the most logical as far as the observation goes, but the paradox remains is that there's no 8 inch per mile squared. That you can falsify the radius, right, by testing and experimenting. So the paradox remains. We have this massive planar system, but we have these opposing rotation bodies. We have certain angles that don't work. I mean, both models have errors, right? I'm just being blatantly honest. I mean, you can take both maps, the globe map and the flat map, and time zones don't work exactly right on a sphere, and the light isn't exactly right on the sphere, and the light on the flat map isn't exactly right. So you've got a lot of these issues, and then what you're trying to do, is compare all of those faults to your observed reality, and of course, it's not going to match up or work, right?
I think it works fine on a globe. I think again, this can be modeled. I don't think this is something that we observe exactly.
Yeah, it's 100% observed. Which, if that observation is true, then it wouldn't happen on a sphere, in a sense that, because on a sphere, when it heads southwest, it completes its circle. But in this observation, it wouldn't go. Obviously, you would have two opposing rotations, like two basic circles on a plane system. But on a sphere, if it's heading southwest, it has to. It doesn't fully complete the southwest rotation, I guess, if you will. It sets in the southwest, but then continues on. I mean, it still goes in a circle, but not in the way you perceive it in Africa. I mean, you would perceive it in Africa to go southwest if it was on a sphere, but it's also an observation creating a figure eight that would be on a plane Earth. So that's the conundrum. That's my observation anyway. I'm trying to figure out how to explain the paradox of an Earth being planar and stationary with opposing rotations, because I'm trying to take my senses and combine it with things outside of my senses, and it's hard. It's a challenge.
I don't agree that we've sort of debunked the circumference. I guess that's probably clear. But would you agree that we can travel to Antarctica by going south from any continent?
That is also, like I said, it's also another paradox, right? You're applying your reasoning to a map, and it doesn't make it's not like illogical. It makes sense, but again, the paradox is the Earth has no physical curvature, and I've flown plane enough, and I've navigated nowhere near a pilot, like minimum 14 hours tops, maybe a month of ground school over the years, peanuts, right? Peanuts. But to my personal experience, I was never taught or trained to fly for a spinning sphere Earth. Now my distances were small, maybe 500 miles. But still, nonetheless, the operation, and when I went to ground school and the simulators, there was nothing about spinning, orbiting, nothing. Right? We operate aircraft perpendicular to the plane and parallel to the plane. Right? This is what we observe. This is our senses. So the paradox is how is the Earth a sphere if to my senses I observe all of this? And so that's where I'm at. That's why I'm trying to build alternative explanations by other observations. And I came across this figure eight. That's observed in Africa. You can go observe it yourself. It creates a figure eight in the sky, not just on your sun and lima on your globe. It actually physically creates a figure eight in the sky. So,
sure, but I think what I would say to that is that we wouldn't expect to need to treat it as a rotating sphere, right? At those distances, at that level, I think it's not exactly a contradiction to the senses. Your senses shouldn't really pick any of that up at that scale. I think when we're talking
Well,
about
that's the paradox, right? That the paradox is the globe is all outside of your
not
senses.
really.
100%. And my experience, this is anecdotal, but because I'm not favoring of the globe or the sphere. I don't care. I'm not choosing either way. I'm actually just trying to figure out how, obviously you've got, like Copernicus says, there's a body of evidence. There's a foot here, there's an arm there, there's a leg there, there's a hairbreadth, and then it builds a human, right? So that's the concept of all of these. You can go observe it yourself. It creates a figure eight in the sky, not just on your sun and Lima on your globe. It actually physically creates a figure eight in the sky. So
Sure. But I think what I would say to that is that we wouldn't expect to need to treat it as a rotating sphere, right? At those.
this is what we observe. This is our senses. So the paradox is how is the Earth a sphere if to my senses I observe all of this? And so that's where I'm at. That's why I'm trying to build alternative explanations by other observations. And I came across this figure eight that's observed in Africa. You can go observe it yourself. It creates a figure eight in the sky, not just on your sun and Lima on your globe. It actually physically creates a figure eight in the sky. So
Sure. But I think what I would say to that is that we wouldn't expect to need to treat it as a rotating sphere, right? At those distances, at that level. I think it's not exactly a contradiction to the senses. Your senses shouldn't really pick any of that up at that scale. I think when we're talking
well,
about
that's the paradox, right? That the paradox is the globe is all outside of your
not
senses.
really.
100%. And my experience, this is anecdotal, but because I'm not favoring of the globe or the sphere. I don't care. I'm not choosing either way. I'm actually just trying to figure out how, obviously you've got, like Copernicus says, there's a body of evidence. There's a foot here, there's an arm there, there's a leg there, there's a hairbreadth, and then it builds a human, right? So that's the concept of all of these concessions of observations being based on a model saying, hey, well, look, the model fits the observation, therefore the model must represent reality. I think that's dangerous in the sense that you cannot match reality 100%. And so to convince somebody that another man has figured in things in totality, I find that's the problem, is that you should never believe another man's totality when it comes to philosophy or things that you can't test or falsify. And so it becomes like an authority position now. It's like, who do you believe to warp or who do you believe in to shape and form your reality? Is it the television? Is it your science educators? Is it debate? Is it
Well, it's a
Myself.
lot of things.
yeah,
But I think
exactly, right?
the main premise that I disagree with is that, like, I don't think that because our local reality looks to us to be flat, I don't think that's a contradiction in terms. That's exactly what we would expect. And to say that we have to rely on one other person or some other guy to tell us what things are, I think is a little reductive in that we can make these generalizations from a larger set of data if we have it. I don't think you need to necessarily take things on faith to model stuff out based on the data and say that, according to various observers simultaneously, the local reality makes sense that we would see it, flat and stationary, but it doesn't work with the greater math.
Well, you can't, first of all, the conundrum would be is trying to take a planar system and putting it into a sphere, or taking a sphere system and trying to putting it in a planar. The math isn't going to work anyway. But not only is the math not going to work, the constructs of the starting numbers of the math are fallacious to begin with. They're just roundabout. They're constants or mean averages, if you will, because there is no accuracy when it comes to the totality. In my opinion, there's not 100% accuracy. Locally, yeah, we can get down to the millimeter for sure. You can observe that, repeat that, test that. But in
Well, you don't need
totality,
100%.
yeah, but that's the
So
thing. There
all
you
you
go.
need is
Yeah, so the
all you
margin of
need
error is
really is
2%,
that
right? The margin of error is 2% on average. That's their claim. As long as we're
sure.
2%, we're okay, right? That's kind of the gist of it, and then most observations that you're made with the sphere are negligible. Motion is negligible, or the centripetal force, the centrifugal force is negligible, but it happens, right? I mean, these are kind of the things you play into for the body of evidence. Is there are measurements, but they're negligible, right? But they're nonetheless, the measurements are there, right? So this is the kind of game with the sphere,
Kind of.
which, yeah, but that's not right, right? That you should
No,
allow
it is
you should
though.
allowing you should allow curiosity, and when somebody says it's negligible, it semantically you're saying, well, you're playing a semantic game at this point. In other words, it's not worthy of measurement, which would facilitate the understanding
No.
of somebody else who opposed the belief, that it would reify their belief that there is no motion. When you say it's negligible, that's enough. Well, I'll give you an example.
That's not what
Okay,
I'm saying. Well, real quick, just to clarify that point, it's not saying that it doesn't matter. What I'm saying is that if we give the 2%, and I don't know if that's a real number, but I'll give you the 2% for our observations to then translate into a flat Earth. The flat Earth would have to lie within that 2%. If that's the margin of error that we have, that we can measure to, then the flat Earth would have to lie within that. But if all of your measurements don't allow for a flat Earth, and you would need like 10% or 15% for that to work, which by the way is more than that, then I think we can
well, your globe
reasonably
model
say that we've excluded that.
Your globe model, when it comes to refraction and GPS, is 5%, guy. You're 5% out in your measurements when it comes to GPS due to refraction.
And the,
So you have
the flat Earth requires 30 degrees of refraction. Like refraction on a globe is something.
You're saying that now. You're saying that now like you have a flat Earth model, right? So show me your model. If you have a flat Earth model that I don't have, and you're telling me that a flat Earth model meets 30 degrees, I'm telling your model already accounts for 5% of error due to refraction in GPS measurements. 5%, man. That's a lot, especially over long distances. That's huge.
I don't know in terms of percentage, but I know that refraction at distance is something on the order of, like in extreme cases, something on the order of like 9 arc seconds. Other people have calculated like 6, but my calculation said 9.
You're looking at 5% error. 5% error over the distance.
9 arc seconds over distance is piffles compared to the 30 degrees that you would need to justify a flat Earth.
But now you're telling me you have a flat Earth, right? That's what you're telling me. What my conundrum is you're taking flat Earth measurements, turning it into a sphere, and then taking a sphere and then flattening it. That's what you guys are doing. No, your measurements are in miles and kilometers and millimeters. Those are linear distances, guy.
Oh?
Come on now. No, don't
What's the circumference of a basketball? What's the circumference of a basketball?
Listen, see, this is what I mean. You guys are not genuine.
What's the circumference of a basketball?
I can take a map right now and put Cartesian.
I'm sorry, you said a very silly thing just now. I can take
a map right now and put Cartesian coordinates on it, XY coordinates, and use Pythagorean theorem and get a distance between 2 points using Cartesian coordinates on a map, guy. So stop with your shit.
And you can describe a circumference in terms of feet and inches. Can you not?
Is there linear distances on Earth, yes or no?
Yes, there's also circumferences.
Okay, awesome. What are they? What are the units for linear? What are the units for linear distances in all measurements? Centimeters?
Units we can use for
centimeters? You don't build a house with any curve, guy.
Whatever you want to use.
You don't build a house with any curve, guy.
That's beside the point. We're talking about
you don't build a bridge. You don't build a bridge with any curve unless you're building an arc.
You can do that with a curve. That's irrelevant. That's
you're not being genuine. They're all linear measurements.
Sorry, I'm not being
Euclidean geometry is not curved.
You're telling me that because the distance is expressed in feet and inches.
Come on, man. Come on, man. Cartesian coordinates don't have curves in them. Euclidean geometry, straight lines and angles don't have curves in them. What are you doing, guy? Why are you being so disingenuous, guy? Why are you being so disingenuous about geometry, guy? If these weren't linear measurements, if these weren't linear measurements, there'd be no reason for spherical geometry, guy. Come on, buddy.
Can you have circles in Euclidean geometry?
The reason why spherical trigonometry.
Can you answer that question?
The reason why spherical geometry has been invented is because of the limitations of Euclidean geometry. That's literally written in the literature.
No, it's not. It's for simplicity. Yes. You can describe a sphere in Euclidean geometry, talk about all of the movements over the surface. But if you want to simplify the math, you just treat the surface as a 2D plane, and you can simplify the math. You get spherical geometry. That's why. Cartesian systems,
but it's the same thing. Level, XY coordinates. I can use Pythagoras theorem to locate a distance using that calculation on a flat map. No curve needed. I can present you 6 miles. I can present you 6 miles of photogrammetry evidence of a city that has linear distances in it, just miles, height and distance, that's it. Height and distance, that's it. Indicating there is no
curves in linear distances.
Again, there is nothing here, and why I know this is because you can take the mathematical numbers of those linear distances and scale them down, and guess what happens? Here's something you should try for yourself. And anybody listening, if you're good at math, take a observation of reality of a city, okay? Preferably at least 6 miles in distance, okay? take
getting
that
off the rails
city,
here.
take that city, okay, and scale it down to 1/100,000 scale. And all you're going to do is two formats. One format with a curved radius, and you're going to scale it down 1/100,000. And then you're going to take another format and just scale it down linear distances. Now, question for you. If I take an observation of 6 miles and I scale it down with no curve in it, and it matches what I scaled down. In other words, there's no deviating verticals. The buildings are, perpendicular to the plane, and everything's parallel to the plane. Everything works like it was flat Earth, right? But when I scaled, take the 1/100,000 scale of the curved surface at that 8 inch per mile square, it doesn't match observation. So what I'm getting at is I can take real life observations, scale them down with no curvature, and they match observation.
Can I ask you a question? Can I ask you a question? Will you answer it? What's the circumference of a basketball?
Depends on, obviously the rate of curve the basketball has.
Sure. Wild stab in the dark. Take a guess.
So, are you conflating something that has physical feet and inches values, something that's tangible?
He's saying that the circumference of a basketball is a rational number.
Yeah, because you have actually feet and inches values that you can tangibly test. You don't have that with the radius of your Earth. This is why you don't have That's why you don't actually have a physical radius value. You have a mean
you're
radius.
Kind of talking everyone out of the conversation, man. Like it's pretty overwhelming, to be honest with you. I don't know if you've had cocaine or coffee and cocaine or just coffee times 2 or something, but
I don't do drugs, dude, just coffee.
It's just actually being shoved down our faces and through our ass.
I'm not certain what you're saying. I'm just replying back to his questions.
I know, but
tend to go on.
I'm being very clear. I'm saying that you're literally just stream of words from your face.
Well, isn't that what you're supposed to do when you have content?
No. What gives the stream of words from your face meaning is the spaces between the words. If there are no spaces, then you're not actually saying anything. It's called communication. You know what Morse code is? If you studied Morse code, you'd learn how to communicate more effectively because it's called spaces. You need to have gaps to make your words have meaning.
It'd be good if the other guy got in on occasion.
Well, when you're dealing with somebody who denies linear measurements, and you can actually take a map can actually physically go take any map right now and go apply the Cartesian formula to it, x, y, and use Pythagorean, you're going to get a distance between the location that's pretty accurate to what you have right now, but you're claiming it's a sphere. But I just used linear measurements and over a 2D surface, and I got the same distance you claim that's on a sphere, right? So this is the thing you should go try out.
All I'm saying,
because the map is scaled.
Again, all maps derive back to Cartesian coordinates. That's the base principle of it all. It all goes back to that first principle. First order measurements is all distance and height elevation. That's your first datum before you put any calculation onto it.
I mean, planar surveying is done over 100 square miles, which means it's 5 miles in every direction. You just added 1 mile, 6 miles.
At 1.5 kilometers, at 1.5 kilometers intervals.
Prove anything. Sure.
At 1.5.
My only point is that, sure, but my only point a moment ago was simply that to say that we measure things in like feet and inches and miles, therefore it can't be curved, is a silly argument because we can measure curves in those same units. That's all.
Yeah, you're deriving the curve from linear measurements is the point. Do you understand? So you're using flat Earth to create your sphere. This is the point.
You're not, though. And I think the evidence of that is that if we were doing that, if we were taking flat Earth and finagling the measurements to get a globe, we would have a bunch of different globes that all went back to flat. But what we have instead is a bunch of flat maps that all translate back into the same globe. I think that in and of itself is pretty compelling.
But they don't. You're lying as far as no, they don't. The land masses are distorted. They're never accurate. This is false. You cannot take a flat surface and scale it to a sphere, and you can't take a sphere surface and scale it to flat without distortion. That's fundamental. Either way it's a sphere, or either way it's flat. You're going to end up with calculation error. This is the issue. You're thinking the mathematics 100%. Listen, guy, you don't even have a radius of your Earth. You don't actually have a physical. You actually don't have a physical radius of your Earth, guy. I know, but you don't even actually have a physical radius of Earth. You have a mean radius. right? Which is it's a fictitious radius. It's not a real radius. Same with your constant 15 degrees. The heavens don't move at a constant 15 degrees, guy. These are constructs. These are constructs.
I've got a question on the Cartesian
reality
thing.
100%, right?
Got a question on the Cartesian. Are aviation sectional maps, VFR sectionals, are they based on Cartesian coordinates?
The first principles are yes.
No, they're not.
Yes, they are. They're all derived from a datum of distance and elevation. The first principle.
No,
yes,
they're
they
not.
are.
Latitude, longitude, 60 nautical miles per degree. That's what they are.
You not at local scale, guy. Local scale is Cartesian. That's all.
So you can argue with the cartographers that make sectionals, but you're saying wrong things.
You have a conical map, which is produced for radar. Radar doesn't flatten for curvature, guy. There is no formula for radar to flatten when they send back signals. Your conical map matches the radar imaging. There is no radiance mile per square in your radar images. They don't flatten for sphere for radar, guy.
There is in some cases.
They don't. Listen, I have it in my book. I read all this stuff, guy. The first principles and the first movers is you measure your curved earth from a flat surface. Any deviation comes from the perpendicular, parallel to the plane, perpendicular to the horizon. All that comes from a planar system, all your measurements. This is just objective in the math. This is not whether it's a sphere or flat.
You know how to do dip corrections?
Okay, so dip corrections now, you're claiming something is dipping due to curve. At what distance are you claiming dip correction?
I mean, dip correction on any long distance.
No, what's the distance you're claiming? What's your distance you're claiming?
I don't know. What's the distance of a particular radar reading?
Doesn't matter. You can have 30, 40, 50 miles easy. There's no dip. There's no dip in the 30, 40, 50 mile conical reading of a map. You don't have all planes fly parallel to the plane, guy, in radar. If you had different planes,
the only where you take a radar, where radar has
look, guy, all airplanes are parallel to the plane. This is what the radar shows. There's no correction for it. It's just capturing reality. Don't tell me that radar is going to fix. Don't tell me radar is going to go fix reality. Radar wants to capture what's happening in reality, not your preconceived calculation of a model.
It's not preconceived. It works. What I'm saying is that a dip correction has a root function in it, which you wouldn't need for trigonometric distances, right? If the dip was just angular to a flat surface, you wouldn't need that.
There is no dip calculation, guy. Where are you using this dip calculation? Show me. Other than the fucking flat debate talking about. Okay, so you have an astronomical horizon and you have a visual horizon. How did you separate the distance between the two of an apparent position that's optically caused? How can you determine the two between a visual horizon created by eyesight and a horizon created by a physical earth? How did you separate the two?
You don't account for it.
No, what you do is you take your vision and you put a mathematical calculation to your vision that used Euclidean geometry. You measured your globe Earth from Euclidean geometry is what you did by taking vision, which is non-Euclidean. Vision converges lines, takes things and changes the well, here's what you have to understand. Our vision doesn't actually change. When we perceive things in spatial relationship to them, they actually don't change size, right? So when we're looking at the horizon, so when you're looking at the astronomical horizon or the horizon in general, that's actually not happening, guy. There is no convergence. That's just a spatial relationship. So when you're telling me that you have an astronomical horizon due to Earth curve, but in your orthographic drawing, you don't account for the apparent convergence. That's not actually happening. It's the illusion. What you do is you hijack vision. You say, well, no, that's not an illusion. That's actually physicality caused by Earth curve when it's not. And do you know how we know? It's because the position of that apparent location changes when we change either height or focal length. Interesting, that, huh?
But you blew right by the radar. What were you saying about radar and aircraft radar a while ago?
So radar is capturing reality, okay? Which means it doesn't account for the dip that you claim, because all it is sending out a signal and bouncing back the signal and catching whatever's parallel to the plane. Whatever is parallel to the plane.
Don't go too far now.
All planes are parallel to the plane. That's what's in the radar.
You're saying that. When you use a plotter, that's not true.
When you use a plotter, you remain parallel to the plane. Whatever height you decided to go at, that will be flat and level for hundreds of miles. How do you know? It's because you can go do it yourself. You can go use a plotter on a 2D map, linear distances.
So my question, you're going way off base. You're going way off base. My question pertains to radar knowing the altitude of the plane at a distance.
There is no diverging verticals in radar. There is no planes that are opposite, planes that are deviating.
Not answering my question. You're not answering my question.
There is no radar that I've ever seen showing two planes apparently at the same altitude height, but one is lowered down because of curve. It's never documented. You would be able to see.
You need to stop talking over him. Stop immediately.
Yeah, I've got the answer. The radar doesn't determine the plane's altitude. They use transponders on the aircraft that tells the control tower what their altitude is. So drop and dip correction in radar is irrelevant.
Thank you very much. Thank you for saying that, because it's exactly my point. Thank you kindly.
Yeah, it doesn't mean anything.
Correct. I agree with you. There is no dip, don't drop, no nothing in radar. Correct.
Doesn't equal flat Earth.
It doesn't equal a sphere either, guy.
That's why I said it doesn't mean anything. So why argue it?
You guys have to say that the wave as it propagates along the surface. Yeah.
Anybody who's willing to look at the mathematics for sphere Earth and want to know how they convinced the average ancient the Earth was a sphere is by hijacking your vision for sure. Because if you think modern technology, where we have cameras nowadays that sees way past the point of the horizon, mathematical horizon, according to your sphere Earth, the ancients wouldn't have had that technology. They would have looked at boats going across the ocean going, oh, well, the boat's going over the curve. Well, it came back, therefore the Earth's a sphere. It's literally the same argument 2,000 years ago that the globers are still using to this day. We have cameras.
That's interesting, isn't it? Why is that not an interesting point?
That is an interesting point. The globers claim to be advanced in technology, but they're using an ancient argument. Interesting, right?
But initially, the ideas of Earth being a sphere and orbiting the sun came from the observation of the sky, right?
Well, it came from a sacred geometry, really, having an affinity
or just observing the sky and plotting it out.
Having an affinity for spherical things is what inspired Aristarchus. And then there were two other authors before Ptolemy two other globalists between the time of Aristarchus and Ptolemy. There was two other authors that created models about the heliocentric model, and that's what inspired Copernicus. Is because back in the day, people were like, you're ridiculous, the Earth isn't spinning. You're ridiculous, the Earth is flat. I mean, Copernicus wrote about how he was, ridiculed for his beliefs.
Yeah, oh fuck, I'm gonna regret this. I want to let Preston get in. He had a lot of feelings about this. I need him to not scream. Please don't yell, Preston.
All right. Data. I'm sorry that I scream when I'm trying. When you go on, it goes over my head, and I'm trying to stop you so that I can take in everything you're saying. Yeah. Okay, and it gets repetitive. So I'm sorry, but I really just wanted to ask. I should have said it better. You are light years more well spoken than me. Okay, so my question should have been like, "Hey, Data, why are you talking about the figure eight over the equatorial position?" And saying, like, do you not believe that the figure eights happen skewed over different latitudes? And does that not become relevant to your dual rotational model?
Well, because I'm only limited on the concept, there have been a few people, I think, in the community that have tried, because I've already tried to model it. When I was dealing with Antonio Subirats, I would discuss with him every so often, and the one thing that I wasn't smart enough to do was model a planar system with opposing rotations. And so I just hummed and hawed for years and years. I was like, well, it has to be a figure eight, or people are living upside down. That's really kind of just the paradox we're in. And just recently, I was like, okay, let's go see if I can find this figure eight. Now, I've already knew about the Sun Alima. I looked at the math. So the Arabics from early 1600s, I may be probably wrong with the date, but they are I believe the Arabic people are the first people to actually mathematically account for, I should say Muslims, account for that sun in Alima. I could be wrong with that, but because it's been a while. So we get to answer your question, what I need to do now is take other points of positions across the equator and to see if, I'm using a 360-degree circle, right? That's not reality 100%. So even if I measure angles and I do all this stuff, I'm still limited to just an observation, right? So I'm just saying if you need opposing rotations on a planar system, you would need a figure eight sun. That particular one observation that I've made so far shows a figure eight, which could allude to the idea of opposing rotations on a planar system. Because if you look at that observation, it wouldn't necessarily work on a sphere in the way that it's perceived to oppose northwest versus southwest. I mean, I understand how it works on a sphere, but if it's opposing rotations, it wouldn't work on a sphere. In the way that I'm perceiving it, right? Which is.
But you're saying basically that's all you need. Yeah, I know you. And for years I've heard you be aware of analemma, reference analemma. It was weird to hear that you're like, well, that's the only one that I know about, the African one. I'm like, there's analemmas at different latitude points. Anywhere. We track the highest point of the sun every day for a course of a year. We will get that somewhat of a figure eight. It'll be a big circle, little circle in different latitudes, although it'll be more of an equal circle of the equator. And I hear you saying you want to go to different points on the equator. That's valid to be like, hey, is it going to be symmetrical at different points? That's interesting. I don't know why it still feels like you are saying you don't need the other latitudes analemma pattern.
I didn't say that at all. It's obviously important to paint a bigger picture. I mean, this is what Copernicus did. But, I've got a body part that suggests this. I got an arm here that suggests that. Let's build a body of evidence, so to speak. So it's like, again, I'm just, whether it's sphere or flat, great, wonderful. My goal is to actually figure out how, the ancients thought about it, the contention behind it, and hopefully tell a great story at the end of it all, which is, you're going to end up believing somebody at some point, whether it's yourself, your neighbor, your friend, or television, you're going to end up believing somebody. So the question is when you end up believing them, is it because you've gone and tested their claims, or you just given up? It's outside of your reality. You can't test it. So I'm just trying to build a body of evidence that would help me understand the paradox that I'm in, which is when I fly, I don't account for curve, I don't account for spin. But there are, anomalies that I can't explain if I think I have a model and I compare it to that model, it doesn't match. So the thing is, well, how do I create that model to match observed reality? Well, I have to leave with a lot of presuppositions. And the easier one, not gonna lie, the easier presupposition is to imagine a sphere, celestial sphere, and you navigate a 2D surface. You take the mathematics of your planar system, you transpose it into a circle, two circles, made in a plate for the astrolabe, and you can rotate these circles, and they intersect on a plane. So the basic maths of that is taking circles, one flat, two semi-sphericals, like a hemisphere or like your vision, and you're rotating over planar Earth, right? So it's interesting. And I find it fun.
We call it what's in the subject. Okay, so when you're saying two rotations, you're talking about maybe two celestial spheres above us. You're not referencing. You're saying we have a plane possibly impossible.
Just one sun following a figure eight path. That's what's observed from Africa for the whole duration. The transition from January to December. You're going to see this figure eight being created in the sky. Right? Forget about the sun in Lima. You're going to see a figure eight, and it's undeniable.
Can we agree on that? I'm going to see a figure eight. You mean the highest point of the sun mapped every day for a year makes a figure eight?
So when you talk northern hemisphere, the peak is going to be not the process between the solstice. Sorry, from the process where it crosses the equator. It's going to be not going to be the high point. The low point It's not going to be the high point or low point. It's going to be the middle point where it crosses over the equator. You can go to Stellarium. You can go see this in action yourself. You can literally see make a figure eight.
I believe you. It's not that I don't believe you. I just can't see it. I thought we were talking about the figure eight created by the high point, which is what it sounded like you walked through the yearly process earlier. Now it sounds like you're saying no to it.
No. I'm not looking at the sun in Alima from the daily picture of the sun when we see it. I'm talking about an observation where you're facing east and you're looking zenith. And so you get to see how the sun in the north traverses east to west, creating a circular motion. And as it comes up to September 20th, you see it cross over, and then it completes another circle for the next few months on the southern hemisphere. And then you see it as you see it cross over again into the north, creating a figure eight. That's what you see. That's what you observe.
So
Not the sun in Alima that you see in photographs for time lapse footage. No. This is actually an observation point where you're looking up zenith from Africa, noticing the figure.
Right. Well, the time-lapse photos are the same thing to me. I don't know why you're making a distinction here.
But they're the same. Yeah, you're right. It's just a different observation.
Let me cover. But you're talking now about what sounds like just the simple phenomenon of the sun, basically what the globe would call traversing between the tropics, right?
Correct. Yeah. Between Tropic of Capricorn and Tropic of Cancer, this transition. Yeah. This from the equinox to the solstice. That's the transfer. So it takes about 10 days for the beginning of the solstice to the equinox, or sorry, from the equinox to the solstice, it takes about 10 days to transfer over. Well, it takes a day, but it changes, right? Because it's going in this oscillating circling pattern, so it's never the same day the next year. It's always a day. It changes.
Mm-hmm.
Anyway, it's just an observation. People can go see it. It creates a figure eight in the sky. Kind of interesting, right? It's kind of what you would expect on a flat Earth with opposing rotations. Just saying.
I don't know that. You got to walk me through this with opposing rotations. I don't know what rotation.
Okay, so what I'll do is I did a video for you in Stellarium. I will post the video in the chat for you so you can see. I took photographs as well. Just go download Stellarium on your phone. Just go download Stellarium on your phone.
Dude, let me ask you. When you say opposing rotations, that to me means two things are rotating. There has to be two things. You have the word opposing, right? What are the two things? Is it the sky and the sun?
In the northern when you go to Stellarium, you will see the divergence. You will see the sky separate, okay, and diverge. Because what's happening is we're taking the apparent rotation of the heavenly bodies. We're using we're using optics where they converge parallel lines into points that don't exist, right? So they're illusions. So what we're seeing is this time-lapse circle rotation. But and you can actually see sometimes the divergence depending where you are along the equator. And of course, that could be distortion from lens. You don't know. But what Stellarium will show you is just basically it's just data at this point, right? So if you look at the data will show you that in the north during the summer season in the north, it will rotate. When you're looking zenith, it will rotate northwest. As it traverses, you'll see it rotate southwest. And the funny thing is when you look up, you'll see it go in opposite direction of each other. Not at once, but over the years. So if you capture in the north here, you capture in the south here, and you look them together, you'll see them moving in opposite directions, which would give you figure.
What's them? What is them? See, I need a pen and paper to take note. I tried to interrupt and say, hey, I'm lost, and you just kept barreling right through me. You said,
okay, I took a photograph. I'll put the photograph in the chat for you. You can analyze the photograph with AI, okay?
Not going to AI. I'm not even smart enough to use AI to analyze a photograph, right? There was one more follow-up. Demox says there's no figure eight. How could you have a figure eight when it's zero or something like this?
Yeah, so you can observe it regardless of what he says. You can observe it. You can from the zenith position. You can see it cross the equator.
Not in the North Pole.
Okay, so you have to be at the equator at the equator. Oh. The point is if the Earth is planar, let's look for an explanation of opposing rotations. So how do we do that? I've tried everything under the sun to model it. I can't. I need a sphere to model the opposing rotations to get all the angles for the most part. Even though the radius of the Earth is much larger than they claim, in my opinion, because the radius value I can't find it. I can't measure it. So it has to be beyond our senses, the size of the Earth. So you lend
Bro,
the idea. Yeah,
opposing rotations of what?
I can't hear you. Say again.
Of what? I've asked you 4 times. You're using the word opposing,
Yeah, so
right?
going
What
from
is opposing what?
northwest to southwest is opposing
What?
paths, right? So the
No,
sun
of
in the
what?
north,
Going from? No, I don't agree. Slow down.
in the north,
Going from the north? Going from what? The sun going from the north?
if I'm facing east in the equator, you're going to see it
Okay.
rise from, you're going to see the sun rise from east, settle northwest. Okay, it's going to set
Sure, that's
northwest.
one rotation. One
Correct.
rotation.
Between September 10th and September 20th, you're going to see it no longer take it'll rise in the east still, but it won't take the path where it now turns from northwest. It will now go southwest, which if you're looking zenith, it will appear to be an opposite of each other. You will have two opposing rotation
That's fine.
circles. Right.
Okay, I
So
don't. The way you're saying
that's a
two
figure eight. That's a
opposing
figure eight.
rotation circles, that term is terrible. That's a terrible term, bro.
Anyway, that's just most people are associated because flat Earth, right? The spelling of flat Earth doesn't explain opposing rotations, right? You can't model a Polaris and a Southern Cross on a flat plane. Right? It's very difficult to do that.
Why are you trying to do it?
It requires a lot of presupposition, and it requires me to believe that the map that I'm using is accurate, which I can't prove that 100%. I can prove locally the maps are accurate, but in totality, I can't.
Thank you for the semi-yielding. Okay, thank you for letting me pick your brain. Okay, I'm the taker. You're the giver. I appreciate that.
I'm not saying it's conclusive evidence. I'm just saying, like Copernicus said, you're looking for bodies of evidence. Well, to get opposing rotations on a planar Earth, you would need a figure eight sun. I seem to have found evidence of a figure eight sun.
You just again you said opposing bodies. It's very confusing. I'm lost. I don't know what bodies are opposing each other now. You were just talking about a
The
pattern
sun is moving in
transition.
the sun is moving so that when the sun crosses from the equinox to the solstice, it changes direction. It goes from northwest to southwest when it settles.
But it's not a different body. The phrase opposing bodies is very misleading, sir.
Fair enough. It's not a different sun or a separate sun. It's one sun taking one path. It traverses in a figure eight over the year. And you can witness this looking at Stellarium. You will literally see it cross in a figure eight pattern. If you speed up the footage, if you speed up the sun path, or click at the months, you have the sun in your frame, and you just keep clicking the months, you will see it transversing along, and it will move back and forth across the equator. And if you play it out in real time, you'll actually see the circles, then it traverse, then the other circles, then it traverse, creating a figure eight.
Yeah, thank you for the clarification, and thank you for the whatever this agreement on or seeing that it sounds misleading to me. Thank you.
Sometimes I may choose my words loosely, not by intention, just probably by rapid thought, rapid talk. So it's maybe speak in air sometimes.
That's fine as long as we say, hey, I'm lost. Like clear it up. I'll always ask for clarification before I attack. Say, hey,
Anyway, go make that observation and let me know what you think. I haven't seen anybody. I mean, we've talked about the sun in Alima. The Arabics, Muslims, when I should go actually look at the date because there was the massive long equation. But the funny part is with that, what the Muslims did with the sun and Alima calculation, the Earth is stationary, right? This is the sun that moves in the mathematics. It's kind of funny. And even in Kepler's equation too, right? When you look at Kepler's laws, he's got two models, and all of his original measurements come from the stationary Earth with the sun moving around. It's right in his literature. I put it in my book.
mm-hmm. They got that good old wobble, man.
So, do you have a comment?
Sorry, hey, No, you're good.
Hey, I just wanted to ask, like, do you have a comment about the dual pole? Is this indicative of a dual pole to you?
Well, I've seen the demonstrations of it. I mean, I've just never put any effort or energy into it. I mean, it would be the only because again, like the paradox exists for me. I see the Earth as a planar stationary system, right? I mean, that's to my senses. Um, okay, I can navigate certain distances using Euclidean, no problem. But then there seems to be methodology of longer the distance, we're going to use some spherical trigonometry, and they're not accurate either. They're off, but apparently it could be, depending on the situation, it could be a closer measurement. So you have two functionalities with two different outcomes, and depending on where you are, either one of those outcomes could give you a better result. That's what I've noticed. So in other words, you could use Euclidean and be just fine with 1.5 mile off. And then, because actually, when it comes to even the sextant, actually, you're still best at 1.5 mile accuracy. It doesn't matter if you add the sphere formula or Euclidean formula, you're still about 1.5. I mean, I'm only basic mathematics here and just not like, don't take, I'm not an expert, right? So I've just minimal experience looking at the first principles, looking at how I would establish, first measurements, learning the process of it. And that's the process.
Make sure them first principles are right, like constant motion and inertial frame, like speed of light being a constant in a vacuum. Got to make sure
Not
them
those
first
first
principles
motion,
are
not
right.
those first movers, like parallel to the
I
plane.
know.
You got your 90. You got your perpendicular to the plane. You got your parallel to the plane. Those first principles to get your elevation profile, right? You're dealing with circles and straight lines, right? Those are your first principles, in my opinion. I mean, I'm using maybe the wrong language to describe it, but
In the context of geometry, yeah, I'm saying in all contexts, we got to make sure the first principles are correct. In geometry, they're a lot more solid than some of these other, scientific philosophies. But yeah, got to make sure the foundation is tight, man.
well, what I find intriguing is even if you practice the Haversine formula and Euclidean geometry for XY coordinates, they both have errors. They're not both 100%. But depending on where you're doing two distances between the 2 points, I mean, this is me comparing a formula to a map that I can't confirm if the map's real or not. But whatever map I choose, it's never from point A to point B, longitude, latitude, it's never 100%. They're either off by like 5 miles, 10 miles, or even sometimes 30 miles, right, between the maps. So even if I do know a distance and I go to try to use formulations between that known distance, I'm still having to rely on a map that I can't verify, which is funny, right?
This hopefully, there'd be a big push like 99. Sorry, hold on. Sorry. Complain. There'd be like 99.9% of more people agreeing, in my opinion, if there was more like walkthrough of the verification of the 3D coordinates of the surface of what we live on. So people, if there was a map, less distorted map where people were agreeing on it, that would get us way more cooperative with each other. We should be able to see eye to eye with the tool like that. But, I got
Well,
to just be
like the thing is for a flat Earth to inherently think the ball is evil or wrong. Well, that would lead to the first programming of the internet, which they came up with the 666 for everything. 0.66 feet per mile squared is the rate of curvature. The traveling around the sun at 66,600 miles, right? I mean, there's other things as well associated to that number. But well, yeah, 23.4, you get a 66.6 degree tilt. Sure, but they're all the reason why that all exists though is because the fundamental 360 degree circle, right? The divisible 360 degree circle. Usually, you got to have some sort of construct to measure reality, and I find that's the construct. It just comes back to 360 degrees, literally that number, and they're taking all their measurements from that 360 degree number.
Yeah.
Oh my God, dude! I don't know why that never hit me before. Yep, that makes perfect sense. It all comes from 360.
They want it to be that way, which is because it could be 100. There could be just 100 degrees in a circle. There could be 400. They could have picked any arbitrary starting point and then sliced it into equal sections. In my opinion, in my math brain, I could be wrong, but that's my understanding. And I looked into the history of it one time, and it is eluding me right now. I'm going to go refresh my memory.
Well,
but
just go
there
look at
was a reason
Aristophanes.
why they chose that. Go ahead.
Well, we'll look at Aristophanes' example. You don't have to leave your home to calculate the radius, the circumference of the Earth. You just have to have an assumed height to the ceiling, and that's done by two equations, really. Well, for instance, take a 360-degree circle. Well, 1/50th of a 360-degree circle is 7.2. Okay, 7.2. Well, that's interesting. That's a main feature in Aristophanes' calculation for the circumference, is that 7.2. Well, I derived that 7.2 just by taking 1/50th of that 360-degree circle. Well, what are the odds now that if I have an estimated distance between 2 points, I'm going to say 500 miles at 7.2 degrees, I do some conversion, take the 7.2 degrees, turn it into to rads, whatever, divide it by the miles, and I'm going to end up with a distance of about 4,000 miles, which is what the ancients used to assume the height of the sun was, 4,000 miles. Well, if I take 4,000 miles and times it by pi, or pi r squared, I'm going to end up with 25,125 miles without
Are you
even leaving
telling
my house.
me?
Without leaving my house, without
Yeah,
even
that's so funny, dude.
So was the height
That's
of the
good
sun
stuff.
that gave them their baseline to the circle degree? As I'm going, okay, I'm almost through the research. Oh wow.
What I'm saying is you don't need to leave your house to create a mathematical model. And Copernicus is an example of it. He created the whole model without a telescope. So you have somebody in 1544 create a model of the universe by candlelight before electricity was discovered without telescopes. So that means conceptually you have the Egyptians created the Babylonians or Egyptians created the numeric system, right? 60 by 60 by 24. It's literally all the Egyptians used. Everything's 60 by 60 by 24. I mean, I'm not talking about times 60. I'm just saying 60, 60, 24 is just kind of like anyway, it doesn't matter. Just go look it up. It's a divisible 360 equation.
Well,
A lot of the calculations can be derived from